Yes, hi children. Today we are going to discuss class 9th mathematics, in which first chapter real numbers. So let us have introduction first. So here, before learning real numbers, let us have some introduction regarding number system. In the set of number system, first set is natural numbers. What do you mean by natural numbers? The counting numbers are called natural numbers. So natural numbers are denoted by what? N. So n is equal to 1, 2, 3, 4 and so on. These numbers are called what? Natural numbers. Why do we call it as natural numbers? We use these numbers in order to count. Such numbers are called what? Natural numbers. Now the next set is set of whole numbers. What is that set? In the set of whole numbers, besides natural numbers, there exists another element, that is nothing but 0. Set of natural numbers including 0 are called whole numbers. It is denoted by the starting letter of whole numbers W. So next set, if you consider, that is integers or Z numbers. It consists along with whole numbers, negative numbers even. So then this set is called integers, that is minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Now natural numbers, whole numbers, integers. Later there exists another set that is called rational numbers. So rational numbers denoted by Q. So here rational numbers are in the form of P by Q, where P and Q are belongs to, what is its previous set? P and Q belongs to what? Set of integers, belongs to integers, where Q not equal to 0. In the denominator, if you consider 0, it cannot be defined, hence the denominator always must not be equal to 0. Next, the other set is irrationals. Irrationals denoted by root n, where n is not a perfect square. These are what? Constraints or conditions which are to be followed in order to define this set of integers or set of rationals. In the set of rationals, what is the exemption? Q must not be equal to 0. And in the set of irrationals, what is the exemption here? N must not be a perfect square. If it is a perfect square, root and square gets cancelled, then ultimately you will get what? Rational numbers. So that is the reason under root, any number if you consider, that must not be a perfect square. Now real numbers, that is our today's current topic, that is real numbers is denoted by R, which is equal to union of set of rationals as well as irrationals. So union of these two sets together, we call them as real numbers. Next, besides this, we learn further one more set that is called in the higher classes, that is one more complex numbers. Just for the sake of idea, we are going to introduce this set, that is denoted by capital C, which is equal to, it is in the form of combination of rational and real and imaginary, where a comma b, any complex number will be in the form of a plus ib, where a comma b are belongs to its preceding set. What is that? Real numbers, previous set. So it belongs to that, and I is equal to, or I square is equal to minus 1, or I is equal to minus 1 under root of minus 1. I stands for imaginary. Under root, if there exists negative, such numbers are called what? Imaginary numbers. So complex numbers is nothing but set of real part as well as imaginary part. So that is the reason we call this set as what? Complex numbers. This is about number system introduction. Now in this chapter real numbers, we are going to study about mainly rational numbers and irrational numbers, their combinations. 1 minute. Mind map. If you consider real numbers, then it is combination of how many sets we have discussed? That is 2 sets. One is what? Rational numbers, denoted by Q. The other one is what? Irrational numbers, that is denoted by Q dash or S, sets also, or R. Next, in this, these rational numbers, it is in the form of what? These are in the form of P by Q. These are in the form of root n. Okay? Set of rational numbers in this format, irrational numbers are in this format, root n. Now, if you convert this P by Q into decimals, how many types you will get here? It becomes as terminating decimal, terminating decimals, decimal format, non-terminating but repeating decimal. Non-terminating but repeating decimals you'll get. Okay. Now for example, if you consider 1 by 4, which is in the form of P by Q, what is its value? 0.25. If you convert this rational number, it will become what? Terminating decimal. After the decimal point there exists fixed number of digits, then hence we call this as terminating decimal. But if you consider 1 by 3, it becomes like 0.3333 so on, which is non-terminating but repeating, recurring. But whereas in this irrational numbers, it is neither terminates nor repeats. Okay, for example, if you consider root 2, which gives us 1.414 so on, like that. So okay, it does not terminate, doesn't repeat a fixed number of digits, and this type of numbers are called what? Irrational numbers. Here if you observe this, the value of root 2, what is the value here? See that 1.4142135. Here there is no certain pattern, and no, that means no proper repetition, and no neither terminate in the sense it doesn't end with a certain fixed number of digits, hence it is neither terminating nor repeating. Such kind of numbers is called what? Irrational numbers. So finally, real numbers if you consider, it is union of two types of sets. One is rational number, other one is irrational numbers. Rational numbers again two types. One is terminating decimal type. The other one is, if it is non-terminate, at least it repeats. It is repeating decimal. But whereas in this case, irrational numbers if we take, it doesn't terminate, moreover it does not repeat. Neither terminates nor repeats. Such kind of numbers are what? Irrational number. Three types of decimals. One is completely terminating, one is non-terminating but repeating, the other one is finally neither terminate nor repeat. Three types of decimals are there. If any number is given, we have to check that based on the decimals, we can conclude that whether it is irrational or rational number. So let us consider exercise 1.1, in which first bit, write any three rational numbers. So as per the definition of rational numbers, generally rational numbers in the form of what? P by Q. So now we can take any two numbers and it can be expressed in the form of what? P by Q. Here that P and Q are what we have discussed, we have considered from rational numbers, in which 3 by 4, 5 by 6, 7 by 9, like that any two numbers we can consider which are integers. That the condition is what? The denominator must not be equal to 0. We can write any numbers in the position of numerator and denominator, but in the denominator condition only 0 must not be written. If you write 0 also, what will happen? Something by 0 is undefined. Suppose 3 by 0 if you written, can you find its quotient? No. That is the reason we do not write here denominator must not be equal to what? 0. So it cannot be defined. So in the denominator other than 0 we can write any number which belongs to what? Integers. Next, second solution if you see, as per this, explain rational numbers in your own words. What is that? A rational number or any number, a number is or can be expressed in the form P by Q are called rational numbers, where what is the condition of P and Q? P comma Q belongs to integers and Q must not be equal to 0 according to our definition. So here, what can write a definition of our explanation of the rational number in the sense? Any number which can be expressed in the form of what? P by Q. Such kind of all numbers are called what? Rational numbers. Okay, but the condition is what? P and Q belongs to integers. Okay, let us discuss the second problem from the first exercise. Give one example each to the following statements. What are the statements? Let us see here. A number which is rational but not an integer. We have to write any number, but it should be a rational number but not an integer. So here if you consider for this solution 7 by 8, it is in the form of P by Q. So hence it is called what? Rational number according to the definition. Here 7 is an integer, 8 also an integer, but 7 by 8 if you write in this P by Q format, then it becomes what? Rational numbers. In the same manner, second one, a whole number which is not a natural number. Whole number which is not natural, for that answer is what? 0. Okay, next, if you consider for this question, third one, an integer which is not a whole number. 0 onwards if you take any numbers, it becomes what? Whole numbers. But if you consider a negative number, it will become what? Minus 4 if you return. Minus any number negative which is negative, minus 10, minus 11 or minus 100, minus 1000, any number we can write. If it is negative, it becomes what? Only an integer which is not a whole number. Next, fourth question if you observe, a number which is natural number, whole number, integer and as well as rational number. We can write its answer as any positive number you can take. Suppose I return 5. So 5 is what? According to see that which is natural number or not? 5 is a natural number. 5 is also a whole number. 5 also belongs to integer and which is also rational number. Why? Because 5 can be written as what? 5 by 1 which is in the form of P by Q. Hence it belongs to what? Rational numbers. Like that. Next, a number which is an integer but not a natural number. It must be what? Integer but not natural. So that means you can take any negative answer, negative number for that, that is minus 10. So it is an integer but not natural. As natural number starts from where? 1, 2, 3, 4, so on, counting numbers. But is minus 10 is included in the set of natural numbers? No. Hence it is called what? Only integer. Third question is, find 5 rational numbers between 1 and 2. What are the numbers given here? 1 and 2. So between these two numbers, we need to find out what? 5 rational numbers. Generally, 1 and 2 are what? 1 is a natural number, 2 if you take natural numbers. Between these two natural numbers, does any other number exist? No. But if we consider as integers also, between that, no other number exists. But we can write n number of rational numbers between any two rational numbers. So let us see how the procedure is. As we required, how many rational numbers? 5 rational numbers. Let us rewrite 1 and 2, that is 5 plus 1, which is equal to what? 6. As we required 5, we should take 1 extra. If we require 10, we should take 10 plus 1. Okay, like that 5 plus 1 as denominator. Now 1 can be written as 1 into 6 by 6. That means what is its denominator become then? 6. In the same manner, 2 if we consider, 2 is equal to 2 into 6 by 6. What does it become? 2 6 are 12 by 2. If you cancel these, again what do you get? 2 itself. If you cancel this 6 by 6, again what do you get? 1 itself. Just for the sake of our requirement, we converted these given numbers as with denominators what? 6 here. Here 2 can be written as 2 into 6 by 6 which is equal to 12 by 6. Now see that there are two numbers now, 6 by 6 and 12 by 6. So this is one is nothing but 6 by 6 and 2 is nothing but 12 by 6, which is equal to 2. Here between this 6 by 6 and 12 by 6, how many numbers we should write? 1, 2, 3, 4, 5 numbers are required. So with the same denominators, we can write the numbers which lies between 6 and 12. What are they? 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. These are our required numbers which lies between 1 and 2.